Today we are going to be showing you the 2010 AP Chemistry Free Response question number 6.
At the top of the whiteboard we have our given equation, which is shown as 2 solid aluminum molecules plus 3 aqueous zinc 2 plus ions, which yield 2 aqueous aluminum 3 plus ions and 3 solid zinc molecules.
Question A reads, write the complete configuration for zinc 2 plus.
Zinc 2 plus is basically the same thing as nickel because it's 2 places back because it has less electrons. So basically you have to write 1s1 or 1s2 and then 2s2 and then 2p6 and 3s2 and 3p6 and then we have 3d10 because we skip 4s2 because it's 2 plus instead of just zinc.
Question B reads, which species, zinc or zinc 2 plus, has the greatest ionization energy? Justify your answer.
Zn2 plus has a higher ionization energy because it takes more energy to remove an electron from an already positively charged ion.
Question C reads, identify the species that is oxidized in the reaction.
Okay, so since we are trying to identify which species is being oxidized, we resort to Leo. Lose electrons means oxidization. So, according to the half reactions, we have aluminum solid gives aluminum 3 plus 3 electrons, and we have 2 electrons plus zinc 2 plus gives zinc solid. So as we can see from the half reactions, aluminum solid is going to be a species that is oxidized because it is giving away electrons.
Question D reads, the diagram includes a salt bridge that is filled with a saturated solution of KNO3. Describe what happens in the salt bridge as the cell operates. Action.
So here we have our salt bridge with our KNO3 solution. As we said in part C, aluminum solid is going to be oxidizing, which means it's going to be giving away electrons, sending it up to the voltmeter to show us a reading. Zinc solid is going to be accepting electrons. Now, as aluminum solution gives away electrons, it's going to become more and more positive because it's losing negativity. That means the nitrate is going to be flowing into this solution in order to bring it to equilibrium. Over on this side, this is becoming more and more negative because it is accepting the electrons. That means the potassium plus is going to be flowing into this solution in order to create this one at equilibrium.
Question E reads, determine the value of standard voltage for the cell.
Here we have our 2 half reactions that we stated above, except now we have the standard voltage for each of the equations. Aluminum was flipped so the electrons would balance out, so this value is positive while zinc's value is negative. And in this problem, we just have to add these two together and you get 0.90 volts, and that's your answer.
Question F reads, indicate whether the value of the standard free energy change, delta G0, for the cell reaction is positive, negative, or 0. Justify.
In this equation, delta G is negative, and we use this equation, delta G0 equals negative NFE0. And in the previous equation, we found that E0 is a positive number, and F is always positive because it's a constant. And then the number of moles is always positive. However, since there's a negative sign in front, it's negative. So in this case, delta G0 equals a negative number.
Question G reads, if the concentration of aluminum nitrate in the aluminum half cell is lowered from 1 molar to 0.01 molar at 25 degrees Celsius, does the cell voltage increase, decrease, or remain the same? Justify.
So for this problem, we're going to use the equation E cell equals E0 minus 0.0592 over N times the log of Q. And Q in this case is lower because it's 0.1 over 1, which makes the log of 0.1 over 1 negative. And so since E0 is a positive number, a positive minus a negative number is going to equal a higher E cell value. So the voltage will increase as the molarity decreases.